In this lesson, we'll go over solving rational equations. We'll apply our understanding of solving equations with fractional coefficients to solving rational equations. We'll learn to check our answers, and then we'll also solve for a variable in terms of other variables when we're given a rational equation. So solving rational equations, some tips. Factor your denominators, determine the least common denominator, get the least common denominator, let go of the denominator like we did in the previous lesson, and then double check to make sure that you don't zero out the denominator. Remember that we cannot divide by zero in math. My math teacher told me you'd go to math purgatory if you did that. I don't know if your high school math teachers told you anything scary like that, but don't divide by zero. So we have to make sure that whatever answer we get does not make the denominator zero. There's also another note here that some rational equations can be solved using cross multiplication, like we did with proportions, but we can only do that when we have a fraction equal to another fraction. Example 1, solve for x. So first step is to get common denominators. Again, I make everything a fraction so that I can see what I have. In this case, the least common denominator is x minus 6. So you go along. This fraction has the x minus 6. This one does. The next one needs an x minus 6, so I'm going to multiply it. Okay. So what I'm left with is 2x minus 12 over x minus 6 plus 5 over x minus 6 equal to 3 over x minus 6. Now that we have the common denominator, we can apply the principle of letting go of the denominator and solving what we have left. A linear equation. We know how to solve this. We get our numbers to one side and our variables to the other. So this becomes 2x minus 7 equals 3. We'll add 7 to both sides. And we get 2x equals 10, divide by 2, and x equals 5. The last step is to check to make sure that the value we get doesn't make the denominator 0 because we can't divide by 0. Also, when you would go to check your answer, they're a little bit more involved because we have fractions, but you would see that you'd get a number over 0. So if we take a look, if we plug 5 in, 5 minus 6 is negative 1, we're good. 5 minus 6 is negative 1 again. This one just had a denominator of 1, so our answer is probably x equals 5. Example 2, solve for x. So I'm going to deal with the negative signs and factoring the denominator. These negatives can go up to the top. We'll put the 2 over 1. This denominator can be factored into 5 times x plus 3. Okay. So now what we're looking at is x plus 3, 5 times x plus 3, and 1. Take a look at what each one has that the other one needs. For instance, these two fractions have x plus 3. This third fraction needs an x plus 3, so that's going to be part of your least common denominator. Second fraction has a 5, the others need a 5. So what we're aiming for is to make sure that every denominator is 5 times x plus 3. For the first fraction, we have to multiply by 5, so we multiply the top by 5. The second fraction has the least common denominator, and the third fraction we're going to multiply by 5 times x plus 3 on the top and bottom. At this point, for the sake of space, I'm going to let go of the denominator. If you have questions about that, feel free to contact me or check out the previous video on solving equations with fractional coefficients. I'm going to let go of the denominator so I can save some room. 5 times negative 2 is negative 10 equals 8. Now this piece gets a little bit tricky. There's a couple different things going on here. What I recommend is multiplying the negative 2 times the 5 first. So this becomes negative 10 times x plus 3, and then now distribute the negative 10. Another linear equation, so you proceed to solve. This is negative 10 is equal to negative 22 minus 10x. So we add 22 to both sides. And then now we divide by negative 10 and simplify as much as possible. The last thing we check is we make sure that this doesn't make any of our denominators equal to 0, which I don't think it does, so x is equal to negative 6 over 5. Example 3, solve for x. So we have 1 over x minus 5, 5 over x plus 3, and 8 over x squared minus 2x minus 15. So we need to factor the last denominator, which factors into x minus 5, x plus 3. Okay, so our least common denominator then, or the denominator we're trying to get everything to, is x minus 5, x plus 3. So this first fraction needs an x plus 3. The second fraction needs an x minus 5. And then the third fraction has the least common denominator. Again, at this point, I'm going to let go of the denominator just to save some space. So 1 times x plus 3 is just x plus 3. Careful with this negative. I would consider this plus a negative 5. So I'm distributing negative 5 to x minus 5, which is minus 5x plus 25 equals 8. Linear equation, I'm going to go through these pretty quickly. So we'd have negative 4x plus 28 equals 8. Subtract 28 from both sides. And we come up with x equals 5. Is that our answer? Check your denominators. No, it's not going to work. And the reason why is if you plug it in, let me change colors here. If you plug it into this first fraction, you would get 1 over 5 minus 5, which is 1 over 0, which is undefined. So in this case, there is no solution. Next, when we have a case that looks like a proportion, when we have a fraction equal to another fraction, you can apply the same principle with common denominators, letting it go and solving what you have left, or you can cross multiply. In order to do that, I'm going to make the 2 negative. So you cross. This is negative 2 times 5x plus 12. That negative 2 has to go to both of those terms. Equals x times x is x squared, not 2x. X times x is x squared. Okay, now we distribute. Negative 10x minus 24 equals x squared. Whenever you have an x squared in an equation, you want to start thinking of quadratic equations. Remember, to solve these, it needs to be in the form of ax squared plus bx plus c equals 0. You know my strategy. I keep x squared positive, so I'm going to move over the 10x and the 24. So now I have x squared plus 10x plus 24 equals 0. Quadratic equations, the first thing you want to try is factoring and solving. This factors to x plus 6, x plus 4 equals 0. And so then our two answers would be x is negative 6 and negative 4. So you can get two answers for these. Again, just double check that it doesn't zero out any of your denominators. Next, solve for x. So we'll use the same idea. I'm going to put my fractions over 1. In this case, we can get all denominators to just x. So for the first fraction, we need to multiply by x on the bottom. Excuse me. Need to multiply by x on the bottom, so we multiply by x on top. Same thing here. Shouldn't be using an x for multiplication. Okay, so now what we have is x squared over x plus 8 over x equals 9x over x minus 10 over x. At this point, we can let go of our denominators. We have left x squared plus 8 equals 9x plus 10. This is a quadratic equation. X squared makes it quadratic, so we want to start thinking in terms of factoring and solving, which means that our entire equation has to be set equal to 0. Okay, so this gives us x squared minus 9x plus 18 equals 0, which factors into x minus 6, x minus 3. And so our final answer here is x is 6 and 3. So with rational equations, they typically reduce down to linear or quadratic. So those concepts are going to come back in this section. Then the additional step here is that we have to make sure that our answer is true, which is always a good idea to check anyway. So solving for a variable in terms of other variables when we have fractions or rational equations, there's 3 different ways to go about doing this. So I'll go through all 3. The first way is you may recognize that if we're dividing by m on the left, so if you multiply by m, on the left it cancels out the m's, and if you multiply by m on the left, you have to multiply by m on the right. this becomes F equals ma. Force equals mass times acceleration. Okay. The second way to do it is to realize that we have a fraction equal to a fraction. Put the right-hand side over 1 and now cross multiply. F times 1 is F. Oops, I didn't solve for m. I'll get back to that. M times a. Okay, so we have F equals ma, F equals ma. We're solving for m and it's being multiplied by a. So in order to get m by itself, we divide both sides by a. And now mass is equal to force over acceleration, or F divided by a. Same thing here. And then the third way to do it is to get common denominators like we've done previously. So your least common denominator is m. So now we have F over m equals a times m over m. You let go of the denominator, and we end up at the same spot. F equals ma divided by a, and m is equal to F over a. So lots of different ways to think about how to solve this type of problem when it's in terms of a variable. Thanks for watching. Please feel free to reach out to me if you have any additional questions.